But at any rate, you've got a standard fuel from a product that's costing taxpayers through mishandling $24 billion a year, according to the Department of Energy's report, U.S. EPA report to Congress in 2004 that Mr. Hanlon cited. He cited the $3 billion research and development, not the $24 billion sanitary sewer overflow cost, but it's in the same report. That gives us a nice budget to work with. I mean, even if you're looking at only a 50% success rate, you've got $12 billion to work with. And you can make a lot of flyers for $12 billion and educate people about saving this and getting it into the fuel stream. Not only that, if you use this as a direct offset against OPEC imports, you know, it's a significant bargaining tool. We're not helpless. We're not just the total consumer. We're actually gaining on independent production. And so I'm very enthusiastic about it. I'm enthusiastic about it from a national pride point of view. I'm enthusiastic about it because I just can't stand the idea of the concept of waste. I think that there's misplaced resources or underutilized resources. I don't think there's waste. Unless you don't do something when opportunity stares you in the face, then that's waste. But at any rate, I'm very enthusiastic about the developments that are being made to convert these waste products and food waste products, which have been just a terrible problem for commercial kitchen collection systems and municipal collection systems. Being able to utilize those using conventional methods, both in the kitchen and downstream to ultimate reuse. So before I get you all standing up and waving your arms and yelling hail, I'll shut up and take questions. Questions or comments?
You mentioned yesterday and today the key time before you actually lose the grease as a resource. What is that time that you need to capture it and use it before the glycerin, before it starts breaking down?
As a general rule, as quickly as possible, because hydrolysis starts to take place immediately upon water contacting a polar hydrocarbon, because water and the hydrocarbon are both polar. It'll dissolve. You know, they say, well, oil doesn't dissolve or doesn't dissolve in water. In this case, it does, because they're both polar compounds. But depending upon the cleaning agents used, because some of the anionic detergents that are being used now can permanently destroy that molecule, completely disassemble it. 2 to 3% of free fatty acids is considered a significant fuel compromise. So if the facility is using soaps, standard soaps, and using them according to the manufacturer's instructions, and you're harvesting that on a 24-hour cycle, you're probably going to get a very saleable product, because your free fatty acid content is probably going to be below 2% if you can get it out of there within 24 hours. Right.
It takes additional resources in the facility to make sure that
Well, and that's where a GRD comes in handy, because they, depending on how they're set, they can be doing it on a once per 24-hour period. They can be doing it continuously, and that's the ideal part, is doing it continuously during the hours of operation, because it removes the oil as it accumulates in the GRD, and with over a 90% efficiency rate, you know, you're making a good harvest. Recovery from wells is nowhere near, oil wells is nowhere near 90%.
once it's removed from the vessel, does the degradation process continue, or are you checking for degradation?
If you can keep the water content below 5%, the hydrolysis rate is acceptable. If it's and the other advantage, of course, is that if it's put in a larger container, less of the total volume is in surface contact with the water. You know, it's like an ice cube. If you take a 1 foot square ice cube, the amount of surface area is, well, whatever the math is on the number of square feet. What would that be? 4 square feet. 6 square feet, right. I always had problems with assembling those blocks. But anyway, if you break that ice cube up, then you have a large surface area. Well, the same is true of oil. If you've got, say, a little bit of oil and 5% water, and then it's in a large flat area, then you have a large surface area relative to volume. But if you have a tall barrel of oil, and you have, say, 10 or 15 gallons in there, and you still have 5%, it's only in contact with that certain amount of that oil. So the hydrolysis rate is impaired. Hydrolysis is a problem for the manufacturers of oil also. We were talking about this earlier today. Humidity condenses in the production tanks, and it's a constant problem for them because once the hydrolysis starts in some of the, especially the high hydrogen content oils, hydrogenated oils, it's almost impossible to salvage enough of that to use, and they frequently have to discard that. And so there's another source of discard fog. And I think it's ConAgra has earned some significant tax credits by putting that in a primary digester and anaerobically breaking it down into methane and using it for power generation that they use at their plant. And I'm thinking it's in Ohio, but I'm not sure. Yes?
Assuming that people don't use the soap in the manufacturer's suggested methodology, and you do get contamination, is the material totally unusable? What happens even if you do get it in the barrel fast enough?
It's not totally unusable. It's just compromised in terms of its cetane value. Let's say you use a gallon and you get a 60 to 70% recovery, and it's a good fresh gallon of fog, and you get a 60 to 70% recovery rate. If you've got excessive, let's say that you're at the 3% mark, for example, in free fatty acids, you can still harvest the remaining attached fatty acids. It's just that the volume of material that you're putting through relative to the therms or BTUs that you're getting out is lowered. The ratio is lowered or compromised. It's not totally unusable. Even in the fatty acid, for example, let's just say that you're way up in the fatty acid content, and it looks like you're not going to be able to make a cost-effective cracking for an ASTM-rated diesel, for example. You can still put that material in an anaerobic digester and make methane out of it. It'll still decompose and make methane. And so you can still make biogas. It's not as efficient, but you can even liquefy methane in these processes and make fuel. But it's a little more expensive. So are you excited? You want to go down here to the hotel and get a bucket and start scooping fog and running to a refinery? There are refineries nearby, you know. Well, let me see if I can find on here my videos. I have some videos here of a GRD, and I also have a video. I'm reminded of the fellow who was doing the hand figures. I have a video here of the I think it's the Honeywell process, the UOP Honeywell conversion process. I think you'll find interesting. I'll take questions in the meantime. Demonstrate, and hopefully we'll get it up, is the adaptability of the grease guard, which is a J.R. Smith trade name, to a GRD. In other words, being able to just simply take off a conventional interceptor, regardless of manufacturer, and put the grease guard on and instantly convert that to a GRD.